There are four major macromolecules of life. What were the four? And how do we remember them? Everybody? Why don't you do that with me? It'll help you remember, right? C for, again, L for, get your mask up. A for, what kind of acid? Nucleic. And P for protein. So enzymes fall under which of the four? It's right on the board. Right there. Enzymes are proteins. All enzymes are proteins. So, what do enzymes do? They act as catalysts, okay? What does a catalyst do? It helps to speed up a chemical reaction. All catalysts do this. Enzymes are a special kind of catalyst. Enzymes are catalysts made by living things. Well, we know that living things make proteins, right? Clap for. So it's not a stretch to get there. Are there catalysts that are not enzymes, that are not made by living things? Yes. Some of the metals up there on that periodic table serve as catalysts for certain reactions, but those elements aren't made by living things. So those metals are not enzymes, even though they help to speed up chemical reactions. The only thing we get to call an enzyme is a catalyst made by a living thing. And they're always proteins. Are we good? Okay, so enzymes are catalysts. Enzymes speed up chemical reactions. There are reactions that absolutely must happen in your body. If they don't happen fast enough, death is imminent. Well, thank goodness you have enzymes, because without the enzymes, those reactions wouldn't happen fast enough. It's because of enzymes that they do happen at that speed. So what do enzymes do? They speed up chemical reactions. Why? Because they're catalysts. All catalysts do that. Enzymes are proteins. Enzymes are these big honking proteins, okay? And they have a specific place on the big protein called the active site. And that active site has a very specific shape, so that only very specific molecules will fit into the shape. Does this make sense? Imagine a jigsaw puzzle. Have you ever put a puzzle together? And it's a very specific shape. This piece goes here because of its shape. Well, you see, enzymes work the same way. Do you see this big blue enzyme here? For those of you online, I'm going to circle it in green. Do you see the big blue enzyme? Well, that big blue enzyme has an active site right here. Do you see how that active site has a very specific shape? So that only a very, very specific molecule can fit in there. In fact, the relationship between an enzyme and the molecule that it works on is so specific, we give it a name. It's called a lock and key relationship. Imagine a lock, right? There's only one key that'll fit into that lock. The lock and the key are very specific. There's not another key that will open that lock in theory. Agreed? The relationship between an enzyme and the molecule it works on is also that specific. A lock and key relationship. Now, enzymes are big proteins and they work on other molecules, and what an enzyme works on is called the substrate. So the enzyme substrate relationship is highly specific. So specific that we call it a lock and key relationship. My back itches. So, enzymes are proteins that speed up chemical reactions. That's what catalysts do. Enzymes work on substrates, and the relationship between the enzyme and the substrate is so specific that we call it a lock and key relationship. You may see it as one other name, and that's a hand and glove. Can you picture a glove on your hand and how the glove contours and fits very specifically? But the Keystone exam tends to favor lock and key, not hand and glove. So take a look here. On this part of the picture, you see an enzyme. This jagged part in red, that's the active site of the enzyme. Do you see how it has a very specific shape? And here's a substrate. But look at the shape of the substrate. It's a mirror image of the active site. That substrate is the only molecule that has exactly the right shape to fit into that enzyme. And when it does, that substrate is either going to get ripped apart or it's going to get pushed together with another substrate. So what do enzymes do? They either rip things apart or they put things together. That's simple, just two things. You good so far? So enzymes either break things down, ripping them apart, or build them up, putting them together. So that's not rocket science yet, right? Just two things. They either break them down or build them up. So let's start from the top and do a quick review. Enzymes work on substrates. Say it. Enzymes work on. The enzyme substrate relationship is so specific we give it a name. All enzymes are. And what do enzymes do? But what does catalyst mean? What do catalysts do? What do they make faster? Chemical reactions. They make chemical reactions go faster. Catalysts. Chemical reactions go faster. And then over here, what do we call this part of the enzyme where the substrate binds? The two words. Active site. So the enzyme has an active site that is the mirror image in shape of the substrate. And only that substrate, that one substrate, has exactly the right shape to bind here. When it binds here, it is either going to get broken down or something else will be added to it to build it up. So it's either going to be made smaller or it's going to be made. Okay, guys, let's move down here just a little bit. I want to talk about breaking down and building up in a little more detail. You ready? Your eyes should be up here. Let's start here. Do you see an enzyme? Do you see this purple enzyme right here? On this enzyme, do you see an active site? Right here. Do you see the active site? In that it has a very specific shape. Do you see the substrate right here? Do you see that the shape of the substrate and the shape of the active site are mirror images of each other? Only that one substrate will bind to that one enzyme. So here we go. We're going to go two directions. And no, that's not a cheesy boy band. We're going this way first. That substrate binds to the enzyme. Do you see right here where it bound to it? And once it bound to it, it got ripped apart and then spit out. So, do you see there's a bond right there holding that together? And what this enzyme did is once the substrate bound to it, the enzyme flexed, just like flexing a muscle. It flexed and it broke that bond right there, splitting this into two pieces. Broke it down. You good with that? So enzymes do one of two things. They either break things down or build them up. Let's go the other direction. Here's our enzyme with its active site. Here are two substrates. These two substrates have exactly the right shape to fit into the active site. The substrates bind to the enzyme. This time, the enzyme's going to flex the other way. It's going to go like this, and it's going to push those two pieces together right here. And a bond is going to form, and then the new molecule gets spit out. So you could spin this either direction, couldn't you? Forward or backwards. Not all enzymes work forwards and backwards, but some do. But the point of this illustration is to show you the two things that enzymes do. This is how it builds up, and if you go this way, you see it breaking down. Notice in both cases, whether you're building up or breaking down, the enzyme was unchanged. That is a key critical point. The enzyme is unchanged. Therefore, the enzyme gets used again and again and again. Any one enzyme could be used thousands of times before it wears out. This enzyme will be reused and reused and reused because it's not changed in the process. And then the final thing, when we bring two things together, when we're building up and making them bigger, what fell out? What's this? What's it look like? It's water. You have a molecule of water that is given off when you build things up, when you make them bigger. But when you break things down, you lose a molecule of water. It uses water to break things down, but it gives water off when you're building them up. One more time. If you're breaking things down, making them into smaller pieces, you have to put water in. But if you're starting with small pieces and you're building up into bigger, it gives water off. Water's released. Okay, you ready for some words? If we go this direction, where we are. So if we go this direction, notice we're starting with small pieces and we're building up into something bigger. If we are making things bigger, what did I say about water? Is it used up or given off? Given off. So if you make them bigger, water's given off as a byproduct, and we call it dehydration synthesis. To synthesize is to make something. If you had to synthesize an essay, what does that mean? You have to compose it. You have to write it. You have to, it's not something you just copy. You have to make it, right? So synthesis means to make. Dehydration means to lose what? To lose water. So you lose water to make something bigger. Dehydration synthesis. You lose water to make something bigger. Everything that's happening is right in the name, isn't it? You lose water to make something bigger. Dehydration synthesis. But on the other side over here, if we were to spin this circle the other way, now we're going to start with something big and we're going to break it down. When we break it down, we have to add water, and by breaking it, the Greek word for to break is lysis. So we have to add water. What's Greek for water? Hydro. And what's Greek for to break? Lysis. Hydrolysis. Hydrolysis. When you put the two together. And you see hydrolysis right here. So spinning this direction where you're building it up and making it bigger, dehydration synthesis. Spinning the opposite direction where you're taking something big and breaking it down, hydrolysis. 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 You good with that? Well, we're going to do a review here, and I'm saving the rest of this for tomorrow. Some new words. Dehydration synthesis. Everything that happens is in the name. Dehydration means to lose water. Synthesis is to make something bigger. Dehydration synthesis. Hydrolysis. Water splitting. Water goes in to split something. Hydrolysis. You use water. Here, you use water. Here, it's given off. And those are enzymes then. So, enzymes work on, your turn. Enzymes work on, again, louder. Very good. Substrates. The relationship between an enzyme and its substrate is so specific we give it a name. All enzymes are, and what do enzymes do? Everybody. Faster. They make chemical reactions go faster. Enzymes have, where does the substrate bind? Active site. Say it. Say it. Again. So, the substrate binds to the active site of the enzyme, and the substrate is either broken apart or built up into something bigger. If we're breaking it apart, we have to add water. What do we call breaking apart? If we're adding water, it's hydrolysis. Hydrolysis. If the enzyme is pushing two things together, making them bigger, we lose water. What do we call that? Dehydration synthesis. Okay, guys, you did great. Copy it. If you're a remote learner, I'll leave this picture up. I want you to copy it. Try to move this just a little bit so you can see the whole thing.